this lesson we're going to verify trigonometric identities using the sum and difference identities. And before we look at the actual identities, I want to answer one question. And that question is, does the sine of 60 degrees plus 30 degrees equal the sine of 60 degrees plus the sine of 30? And another way of asking that question is, does the sine of a sum equal the sum of the sines? And the best way to answer this is to evaluate each side. So the left-hand side, the sine of 60 degrees plus 30 degrees is actually just the sine of 90 degrees. And the sine of 90 degrees is equal to 1. The sine of 60 degrees is equal to the square root of 3 over 2. And we want to add that to the sine of 30 degrees, which is 1/2. So the right-hand side is the square root of 3 plus 1 all over 2. These two are not equal. And so the sine of a sum is not equal to the sum of the sines. And listed below I have the trigonometric identities for the sum and difference for sines, cosines, and tangents. And you will not be responsible for the proofs of these. You can look them up on the internet, you can look them up in a textbook, but for now I want you to be able to use these identities to verify other identities. One of the initial purposes of these trigonometric identities to evaluate trig functions without using a calculator, because they didn't have a calculator. And although this is something that is not as useful today, it's still worthwhile seeing how it's done. What we're allowed to do is we can evaluate the cosine of 15 degrees using our calculator. But suppose you didn't have a calculator, how would you approach that? Well, what we try to do is rewrite the cosine of 15 degrees using special angles that we know the trig functions of without a calculator. And so I'm thinking of angles like 0, 30 degrees, 45 degrees, 60 degrees. And so we either write 15 degrees as a sum or a difference of two angles. And so when I look at this, I think of 45 degrees and 30. Cosine of 15 degrees is equal to the cosine of 45 degrees minus 30 degrees. And we can use the difference formula for cosine. So we have the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. We can evaluate each of these individually. The cosine of 45 is the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2, plus the sine of 45 degrees, which is the square root of 2 over 2. The sine of 30 degrees is 1/2. When I simplify these, I'm going to get the square root of 6 over 2 plus the square root of 2 over 2. So I get the square root of 6, over 4. I get the square root of 6 plus the square root of 2 all over 4. And that's considered an exact, the exact value. Now we could just pull up our calculator. Let's evaluate the cosine of 15 degrees on our calculator and compare it to the answer we got using the sum and difference formulas. So my calculator is in degree mode. The cosine of 15 degrees is equal to approximately 0.9659. Now we'll evaluate the square root of 6 plus the square root of 2 over 4. Second, square root of 6. Again, for those of you who have older versions of the calculator, you'll probably need to close parentheses. I just have to hit the right arrow to get out of the square root, then hit plus second function square root of 2, and then I'll hit the arrow key. So I'm just going to hit enter and evaluate the numerator and divide that answer by 4. The other option is to just use parentheses. But you can see here that we get the same exact answer. And so really this is just a demonstration of how these sum and difference identities were used long ago, before you had calculators and the technology that we have today. So I'd like you to pause the video and try to evaluate the cosine of 75 degrees, either using a sum or a difference identity, and then start the video to check your answer. I'm going to rewrite the cosine of 75 as the cosine of 45 degrees plus 30 degrees this time. I'll use the sum formula for cosine. I get the cosine of 45 degrees times the cosine of 30 minus the sine of 45 degrees times the sine of 30. We'll evaluate these individually. We've got the cosine of 45 degrees is a square root of 2 over 2. Cosine of 30 is 1/2. Square root of 3 over 2. The sine of 45 degrees is a square root of 2 over 2, and the sine of 30 is 1/2. So we get a similar answer, only the sign is different. We get the square root of 6 minus the square root of 2 over 4. And again, let's just check this on the calculator. We're going to take the cosine of 75 degrees, evaluate that, and then we'll evaluate our expression, the square root of 6, this time minus the square root of 2, evaluate that, and then I'm going to divide by 4. And we get the same exact answer. So the purpose of using sum and difference identities to evaluate trig functions of angles is pretty archaic, but again, it's more of a lesson in history. What's more useful to us is using these identities to simplify or verify expressions. It does help us in calculus when we're taking derivatives to deal with a more simplified expression. So the next video we're going to use these for that purpose.